Hey there, everybody. Welcome back. We're going to continue 6.3. We are looking at the slope of a line. And in this one, we're going to look at the slope-intercept form of an equation. You actually graphed one of these earlier. The slope-intercept form of an equation is y equals mx plus b, where b is the y-intercept. Well, 0 comma b is the y-intercept, and the slope is m. And I think the easiest way to do this for you is to show you an example. So let's start off with y equals 3x minus 2. I think this is one of the ones we did the other day. No, we did y equals 3x plus 2. Let me change it up. We're going to do y equals 4x minus 1. So the slope here is 4, which is 4 over 1. My y-intercept is 0 comma negative 1. So what you do is you start off, put a point at the y-intercept. Boom, 0, negative 1 is right there. Then B, using rise over run, so I am going to rise 4, and I'm going to run 1. So I've gone up 4 and right 1. I can keep doing that. I can go up another 4 and right another 1. So I did it again here, up 4, right 1 from the last point. Another way of looking at that slope, if you want to go the other direction, is when m equals 4 over 1, that's also the same as negative 4 over negative 1. So here I could go down 4 and left 1. So I'll do that. I'll go down 4 and left 1. I'll do it again. Down 4, left 1. And the dots, if you've got a good setup, I'm sketching it by hand and not using graph paper. That's what it's going to look like. All right. Let's take a look at another example. Let's start with one that is not in the slope-intercept form. So let's do 3x minus 5y equals 15. This was the standard form, and we want to, there's no m in this form. So we want to write it in slope-intercept form. Which means isolate y. Get it by itself. So I'm going to start off, I'm going to subtract 3x from both sides. And then I'm going to divide everything by -5. And I'm going to get y equals 3/5 x minus 3. And I canceled the negative there, but I don't. I have 3/5 or -3, -5. I don't know how many I'm going to need. I want to show you another idea here as well. So, and what's my y-intercept? We take this value here at the end and we put it in at the end of 0, comma. So 0, -3. So 0, -3 is right there. That's my y-intercept. I am then going to go 3/5 is up 3, right 5, which is rise 3 and run 5. So up 3, right 5, 1, 2, 3, 1, 2, 3, 4, 5 puts me right there. I could go another 3 and write another 5. Or I could do the -3, -5, which would be down 3 and left 5. Boom. All right, ready for more? Let's take a look at we are gonna, let's try 2x minus y equals -4. So if I subtract 2x from both sides, I get -y equals -2x minus 4. Let's go with 2x minus y equals -3, because I want to show something here. And it'll work better if 2x, if that's an odd number. Then we divide everything by a -1. And 2x minus y equals -3 turns into y equals 2x plus 3. Okay. Ugh. So my slope here is 2. If I want it as a fraction, it's 2 over 1 or -2 over -1. My y-intercept is 0, 3. So let's put some slashes on this bad boy. If your notebook is graphing line, this is a lot easier. Like that's how my notes are. I use graph paper book. Do I actually graph in it though? No. Because I've been doing this long enough that I know what I'm doing and I don't need that picture there. All right, so 0, 3 is right here. And then I'm going to do a rise of 2 and a run of 1. And I'll do this a couple times. Or I could do down 2 and left 1. So this is graphing using the slope-intercept method. If you want to kick it up a notch, by graphing both intercepts, by graphing the x-intercept or the y, x and y intercepts. Now, we already have the y-intercept, that's that. But we really want to focus on where's the x-intercept. For the x-intercept, y equals 0. It's the point x comma 0. So is I'm going to make y equals 0. If I had y equals 2x plus 3, 0 equals 2x plus 3, subtract 3, divide by 2, and I get x equals negative 3 over 2. Which is the same thing as negative 1.50. We can see that right there. Negative 1.50 is right there. So what this does is by graphing the x-intercept, we verify we didn't fuck up the other one. Slope-intercept. So if you do both, kicking them together, making this all one, I guess you could call this the slope-intercept method. This is something I picked up from Mr. Blakely. Slope int, because it's got the x-intercept and y-intercept and the slope. We're using all of those to graph. Okay, let's do one more. Oh yeah, let's make it rough. 1/2 x plus 2/3 y equals 4/3. Yeah. Why? Because I can. That's the power of being El Jefe, the professor. God, that doesn't look good. Let me rewrite that. So what I like to do here is I like to say, fuck fractions. I don't want to work with them, so I'm going to clear them. Clear by multiplying by LCD. I can see the LCD is 2 times 3, which is 6. I will multiply both sides by 6. When I distribute, I get 6/2 x plus 6 times 2 is 12 over 3y equals 6 times 4 is 24 over 3. This turns into 3x plus 4y equals 8. Now I'm probably going to have fractions at the end, but at least I'm not trying to get a common denominator and add, subtract fractions. Now I can subtract 3x. And I can divide everything by 4. Y equals negative 3/4 x plus 2. So here I can either have the negative with the 3, or I can have the negative with the 4, which helps us do our left and right thing. My y-intercept is 2. 0, 2. It's actually a point. It's not just the 2. So if I graph that, zero, 2 is right here. If I do the negative 3, 4, it's rise of negative 3, which is down 3. Run of 4 is right there. If I do the 3, negative 4, it's up 3 and left 4. So I'm going to turn this sideways real quick because it's easier for me to draw a straight line going away from me or towards me. All right, now we'll do the intercept for the x-intercept. For the x-intercept, y equals 0. I'll do this in this equation. 3x plus 4 times 0 equals 8. We don't need the 4 times 0. 3x equals 8. Divide by 3. X equals 8/3, which is approximately 2.67. Which should be right about there. 2.67 is right about there. It where I did it, it looks like 3.0, but that's because I'm not using graph paper, so it looks bad. If I had it correctly, it would look a little bit more like that. If these were all evenly spaced. Okay, so really is 2.67, 0. So I can see my graph isn't perfect, but it gives me a ballpark of where it is, and the red points are correct. All right, that'll wrap up 6.3, where we don't got a lot left. This stuff isn't too bad. Chapter 7 is actually pretty quick. Chapter 8's probably got the most work of what's left, but we're almost done. Peace.